Okay, so let's see, question 9.2. It says the following. There's a chord MN. I stop reading, QN rather. I stop reading immediately. What does it mean for something to be a chord? It means it is straight. A chord is a straight object that runs from one side of a circle to the opposite side, where it carries its name then as QN. Okay, so they say that chord, sorry, why is that important is what I wanted to talk about. Because you have got quite a few theorems where it says the radius is perpendicular to the tangent, okay? Or the radius bisects the chord, or the chord subtends angles on the circumference. So these words are key words for you to start filling in things on your diagram. Let's read on. It says the chord bisects the angle MNP. We stop reading, we go to MNP, and we indicate that that angle there is bisected by bringing in a symbol. So let's put that symbol down for the fact that those two angles, and it's just for clarity, show a one-liner that runs through it. Okay, then they say it intersects the chord. There's another chord, MP, at S. Now remember, guys, the word intersect in geometry means they cross one another. Okay, so my fingers are intersecting here at that point where they cross one another. That's the point of intersection. Okay, so they also told us it's a chord. Let's see why that was important. They said MP over here is also a chord, and it's intersected by this chord at S. Now that is key knowledge for us to have, folks, because for us to talk about MP as a chord means it is straight. It's a straight geometric object. So we're going to look for, if two chords intersect, the vertically opposite angles that are equal. One of these chords I see, we haven't read it yet, but we're getting to that point where we're going to read that there's parallel lines. And if you have parallel lines, the line that crosses them have to be straight. It has to be a line that is, by definition, straight. Okay, let's read on. Intersecting at S. If I want to, I'm just going to put two dots there and maybe a cross there to show and remind me that these angles, let's put two dots because of that dot at the center. This is equal to that vertically opposite. Those two are equal vertically opposite. That's all we can say so far. Now look at this. The tangent at P. So at P, there's a tangent. Now that tangent clearly is this line over here. Okay, I stop in my tracks and I've read the word tangent. Now remember, 3 theorems on tangents. The tan-chord theorem is one of them, the radius being perpendicular to the tangent. And if there's 2 tangents from the same point outside of the circle, then those 2 tangents will be equal. Those are our 3 tangent theorems. Let's see which ones are here. If this is the tangent line over here, the angle between the tangent and the chord, let me use a green, that angle is equal to the angle in the alternate segment. Now here's the chord. The angle between the chord and the tangent is equal to the angle in the alternate segment. So M2, let's give it 2 lines, is equal to P1. So both of these angles are X. Okay, let's see, is there a radius? No, there isn't, because we were not given the center of the circle. There's also no other tangent that runs to the circle. What we can, however, say additionally is that this full angle over here, and I'm going to make it a blue dotted angle, There's the tangent, here's the chord. Okay, there's the chord MP. It's equal to the angle in the alternate segment. So P1 plus P2 is equal to Q1 plus Q2. And you'll see just now why that is going to become important. Okay, then we go back and it says it meets MN produced. I stop reading. Listen carefully, matrix. If I tell you a chord has been produced, it means that this whole object is straight. Okay? So if I tell you something is produced, MNP, you have something that is straight. If it goes over the circle, if the reason that we're telling you it's straight means there's exterior angles going to come into play later. And those are the theorems that you forget, because the easiest one you learned was when you were in grade 9 or 10, when you learned about the exterior angle of a triangle. Don't forget that one. Okay, let's read on. It is produced to R. Okay, so they told us that that line, that is indeed a straight line. From M to R, we have a straight line. Okay, we'll come back to why that is important in a second. Okay, so it says it meets it at R, such that, and this is what I was burning to read, we could see that they were parallel because it was filled in on the diagram. But we have to read it as well. So here, this line is parallel to that line, which is now going to make this diagram look like a circus when I start working on it. Let's see. I go, first of all, I'm going to turn everything orange. I have a line here, QN, that is parallel to RP. If you look carefully, RP, QN parallel. So this angle here is equal to that one over there. Angle P1 equals N1. Why is that the case? They are alternate angles. So I'm going to turn this one into a one-liner, or let me turn this one rather. Let's leave that one. Let me just undo that line. And let's turn this one into the yellow angle, a yellow one-liner. But now look at the beauty here. By the tan chord theorem that we applied, this now also becomes a two-liner. So this is X, that is X, and so is that on my diagram. So far. Okay, I can also see that here's a line, RP is the chord, SN is a part of a chord, but it's parallel to that one. So if I collect my blue pen, those two angles are indeed equal. Okay, folks, now we go over to phase 2. We finished with phase 1. Phase 1 dealt with the information that they gave me. Now I'm going to look for hidden information. Okay, you're going to see what I mean by that now. So the first hidden information is there a cyclic quad? Let's have a look. Well, if I look at the picture here, definitely. A cyclic quad is defined by 4 points that lie on the circle. So let's collect the blue. The exterior angle, remember I said exterior angle because they told you the line is produced, is equal to the interior opposite. So those two angles are definitely equal to one another, exterior angle of that cyclic quad. This little angle is not an exterior angle because it's not formed by a side that has been produced. Okay, what else can I say? Let me collect the orange. I've got the cyclic quad. Now look at this, folks. Here, I've got another one of those. Angles in the same segment, another X. Here, angles in the same segment, another X. All of this happened the moment these lines became parallel. This is what happened to our diagram. Okay, we hit the parallel lines. Now everything all of a sudden changes their relationships. Let's see if there's more that we forgot about. Yes, there's one. Look here at PQ. At PQ, it subtends the x at the top. So at PQ, it will subtend the x over here as well. Okay, so that is insofar my angles in same segments are concerned. And then I can say that this angle here at Q1 is equal to the angle at P2 for the same reason subtended by the chord MN. Okay, I think we have an enormous amount of information on our diagram. Let's see, what does the first question want us to answer? And that's on my next page. The first question says, determine the following angles in terms of x. So we're working with angles in terms of x. Please, guys, notice the mark allocation. So I've got N2 that I want to find, and here determine the following angle. Also in terms of x is a Q2. Okay, so let's have a look. A and B. Number N2. Let's go back. Let's see where number N2 was. Well, N2 was this angle. And remember, that's where everything happened. The lines became parallel, hence my angle that was between the tangent and the chord became equal to the alternate angle on the other side. That's how it happened. So let's see how we write down the reasoning. And this is the important step. P1, or we can start by saying the two lines are parallel, and then that P1 was equal to N2. Okay, so the two lines that were given as parallel was SN, or rather QN, whichever one you want to choose. QN is parallel to PR. That was part of the given, and based on that, given to us, we can say P1, which is equal to X given, is now also equal to that N2. And the reason for that was tan chord theorem. So we've got our two marks in P1, N2 was equal, they both equal to X. That was given. Remember, this is the component that was given. This became equal to, it's not the tan chord theorem. Let me just remove that. It's because the lines were parallel, so it is alternate angles that are equal. So alternate angles equal, and you're basing it on the fact that those two lines are indeed parallel. Okay, so we're going to use the tan chord just now. Let's go back. We want to see where Q2 is. Q2 is down here at the bottom. Okay, here is our Q2 that we need to relate. Now, how did this become an X? Well, let's see. P1 became equal to M2, the tangent chord theorem. So that's our first statement. P1 equals M2, and then M2 will equal Q2 because of the angle in the same segment. So let us write that down quite nicely on my next page. Let me go and get the arrow. Okay, let's rather use the mouse. It seems that my pen, there's it, my pen is going on strike. Okay, so let's write out what we just said we saw. Remember, it started with the tan chord theorem. So first of all, P1, angle P1, was equal to angle M2, and they both are equal to X, and that was because of the tan chord theorem. The very next statement we're going to make is that M2 was equal to Q2, which is the one that we wanted. which is also then equal to x. And the reason for that is angles in the same segment. So we're acknowledging two things. We're acknowledging where it's starting, and we acknowledge what happened after that in part B. Let's see what they want us to show in part C. And this is where the matric work comes in, folks. It is a 6-mark question. They're asking us to prove, giving reasons, that mn over nr is equal to ms over sq. Now let's see where that lies. Mn, let me just get, let's use the blue over here. There's Mn. I want that over Nr. There. They say, prove giving reasons that this is the case, that Mn over Nr is equal to Nr, which lies, Ms rather, which lies over here, over Sq, which lies over there. Now that looks strange. That looks very, very strange, because we know if things are parallel like they are, then Mn over Nr, our theorem tells us that Mn over Nr is equal to Ms over Sp. That's what the theorem says. And our reason is our sides are in proportion because our lines are parallel. So we're calling on the proportionality theorem that we learned in grade 12. Okay, but let's see what changed. If I look at where Sp is, or Sq, it lies here, and Sp, the other line, is actually there. But what do I know? I know that this angle P3 is equal to angle Q2. Now, I can't just go and say that P3 is equal to Q2 is equal to X. I need to reason how that happened. That's where the marks come in. So we need to think about, how did P3 enter the picture? So let's see. If I look at where P3 is down here. P3 was equal to N1 that lies up there. Okay, and that N1 and P3, those two being equal. Oh, and we forgot another one. There's an R over here that's also equal to the N1. So we could possibly try and use those. Okay, so let's see. Let's write out our argument. I'm going to write our argument on this page, folks, because we'll have to jump between the pages all the time to come back to the diagram so you can see what I mean. So let's start off and let's acknowledge. We've already acknowledged that the lines are given as parallel, and we've acknowledged this. Why is this the case? Why is Mn over Nr equal to Ms over Sp? Is because the sides are in proportion from our parallel lines. Okay, so now we can start constructing our argument. N2 was equal to P1. Angle N2 was equal to P1, which is equal to X. We had that above. We don't have to state that reason again. But what did we learn right in the beginning? We learned that this angle was bisected. And there's our link. This angle was cut in half by the chord QN. They told us right in the beginning, they said QN bisects the angle MNP. So we're going to say but here at this point. N1 equals N2 is equal to X. And that was just given to us right from the beginning. We're putting it equal to X because N2 comes into this picture as well. Okay, so that's our second step. So what can we make from that? We can say also that N1 here, N1 up there, is indeed equal to angle P3. And that makes it equal to x. And why is that so? Angles in same segment. Now remember, we're wanting to prove that these two things are equal. That's where all this reasoning is supposed to go. So we want to end up with something that says that Q2 is equal to P3. Okay? We need to bring in that argument. So let's see, are we ready to say that? What is Q2 equal to? Okay, so we've had Q2 was equal to M2. Is it in any way equal to something that lies over there? This was a tan chord equal, that is same segment equal. So we can go from M2, which was equal to P1, and we can say also that P1 is equal to M2, and that is equal to x. Okay, and this here was proven already by the tan chord. So this was above, and then therefore M2 is equal to Q2. Okay, now remember, that comes from also our argument that we had in our previous case. So we can now state that P3, angle P3, is equal to angle Q2. Okay, we've got those two angles equal and can then say now that SP is indeed equal to SQ. Why is that the case? Those are sides that lie opposite equal angles. And because those sides lie opposite those equal angles there, they are indeed equal. So we can now go and replace the SP in here with the SQ. And that is what they wanted us to prove. So we can finally conclude that Mn over Nr is equal to Ms, which is what we had, over the SQ. Quite a long problem. It was there for 6 marks, folks. So you have to remember how your matric theorems and your grade 11 theorems sort of intersect in problems like this. There's not a grade 11 question separate from a grade 12 question. All the geometry comes together in a particular problem like this.